today we will start Chapter 12, Standard Functions. The objectives of this session are: study and interpret the sense of variation of a function algebraically and/or graphically. Prepare the materials, if you please. And these are the prerequisites. First, we will start with the definition of a constant function. In fact, consider a function f defined over an interval I. F is called constant if for any number x on this interval, f of x is equal to k, which means that f of x is independent of the value of x. F of x is equal to a constant number, okay, where k is a real number. The first example, choose the constant function. 1. F of x is equal to 5. Here, the function is constant since if x vary over the domain of definition of x, f of x will remain 5. F of x equal minus half, this is also a constant function. F of x is equal to 2x plus 3. In this case, f of x depends on the value of x, so it's not a constant function. This is the solution. Application 1. Please stop the video and try to solve the application. The sense of variations of a function. So we have two cases, an increasing function and a decreasing function. We will start with the study of the sense of variation of an increasing function. Consider a function f defined on an interval I by x, f of x. F is called strictly increasing on I when, for any two real numbers x1 and x2 belonging to I, if x1 is less than x2, then f of x1 is less than f of x2, which means when x increases, f of x increases. You see, here x2 is greater than x1, then f of x2 is greater than f of x1. Or we can study the sign of f of x1 minus f of x2. Example 2. Consider the function f defined on R by f of x equal 4x. Show that f is strictly increasing on R. Now, how to show that a function is strictly increasing? First we will start by this statement. We have to define x1 and x2 such that x1 is less than x2. Let x1 and x2 be any two real numbers belonging to R, which is the domain of definition given in the example, such that x1 is less than x2. This is the statement in which we have to start. Then the second step is to calculate f of x1 minus f of x2. You see, f of x is equal to 4x, then f of x1 is equal to 4x1 and f of x2 is equal to 4x2. We can take 4 as a common factor. We will have here x1 minus x2, and since x1 is less than x2, then x1 minus x2 is negative. So f of x1 minus f of x2 is negative, then f of x1 is less than f of x2 and f is strictly increasing. Now, this is the application. Please stop the video and try to solve it. Here, as you see, the domain of definition is 0 plus infinity. So in the first statement, we have let x1 and x2 be any two real numbers on 0 plus infinity such that x1 is less than x2. We have calculated f of x1 minus f of x2 and studied its sign to conclude that it's negative. So the function is increasing on 0 plus infinity. Now, the sense of variation of a function, decreasing function. Here, consider a function f defined over an interval I. F is called strictly decreasing on I when for any two real numbers x1 and x2 belonging to I, If x1 is less than x2, then f of x1 is greater than f of x2. So as x increases, f of x decreases. You see, x2 is greater than x1, but f of x2 is less than f of x1, or f of x1 minus f of x2 is positive. Example 3, consider the function f defined on R, so this is the domain of definition, by f of x equals minus 4x. Show that f is strictly decreasing on R. So let x1 and x2 be any two real numbers belonging to R such that x1 is less than x2 or x1 minus x2 is negative. F of x1 minus f of x2 is equal to minus 4x1 minus 4x2. And we can take minus 4 as a common factor. We will obtain minus 4 into x1 minus x2. x1 minus x2 is negative. Minus 4 is negative, so the product is positive. Then f of x1 is greater than f of x2, and therefore f is strictly decreasing on R. Application 3, please stop the video and try to solve the application. So this is the solution. Graphical interpretation. What does the sense of variation mean when it comes to the curve, to the representative curve of a function? Let's start by the constant function. This is a constant function. You see, it doesn't increase, it doesn't decrease over its domain of definition. It's constant. So the curve C in the adjacent figure represents a function defined on an interval I, A, B. Now if M is any point on C and M moves from A to B on C, which means it moves horizontally, then f of x remains constant and C represents a constant function on I. Now an increasing function. This is an increasing function. The function increases while x moves from A to B. As you see, this is M1. So this is M1, this is x1 and f of x1. And this is M2, x2 and f of x2. As you see, when x1 is less than x2, f of x1 is less than f of x2. So the function is increasing. Now the decreasing function, it decreases as x moves from A to B. This is the point M1 with x1 and f of x1, and the point M2 with x2 and f of x2. As x increases, here notice that f of x decreases. It moves downward. Now, example 4. Study the sense of variations of the function f defined on R by its representative curve C as shown in the adjacent figure. As you see, this function is defined on R and it has several senses of variation. First, it's increasing, then decreasing, then increasing. Now, if you have to study the sense of variations, we have to study it according to the values of x. We say that from minus infinity to minus 1, to x equal minus 1, the function is increasing. And from minus 1 till 1, the function is decreasing. Then from 1 to plus infinity, the function is again increasing. Please stop the video and try to solve the application. Now, here are some properties concerning the graphical interpretation of an increasing or decreasing function. If an even function f is defined on interval minus a, centered at 0, is strictly decreasing on minus a 0 as you see here, then it's strictly increasing on 0a. So if it's decreasing here, it's going to be increasing on the other side. But if the function is odd, and if it's decreasing over minus a 0, it's also decreasing over 0a, or vice versa. If it was increasing, it will be increasing over also 0a. Consider the function f defined on R by f of x equal minus x squared plus 3. We have to show that f is an even function, that it's strictly increasing on minus infinity 0 to deduce finally the sense of variations of f on 0 plus infinity. So first, the domain of definition of f, which is R, is centered at 0. And if we calculate f of minus x, it's equal to minus x squared plus 3, which is equal to f of x. Then f is an even function. Now to study the sense of variations of f on minus infinity 0, let x1 and x2 be two real numbers on minus infinity 0 such that x1 is less than x2. We have to calculate f of x1 minus f of x2. So we'll obtain x2 minus x1 into x2 plus x1. x2 plus x1 is negative. Why? Since x1 and x2 belongs to minus infinity 0, so they are both, or at least one of them is a negative number. And x2 minus x1 is positive. So the function is increasing or strictly increasing on minus infinity 0. Now, since the function is even and it's strictly increasing on minus infinity 0, then it's strictly decreasing on 0 plus infinity.